Hello, fifth graders. So last Friday, you guys had your Topic 7 quiz, which was all about simplifying fractions and adding and subtracting fractions. What we're going to get into now in Topic 7 is estimating sums and differences of mixed numbers and just mixed numbers in general. So adding mixed numbers and subtracting mixed numbers. Now, before we begin, I want to review a couple things from fourth grade. Some of these things you may remember, some of these might be new to you. That's why I kind of want to go over this just to make sure everyone's on the same page. So first, I just want to review a little bit about a simplification, just to kind of get your mind refreshed. I know it's a Monday. So 6/8. Can 6/8 be simplified? Yes, 6/8 can be simplified. They are both even, numerator and denominator. So if they're both even, we know that we can divide top and bottom by what number? If they're both even, you always know you can divide by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. And we cannot simplify that fraction any further because the numerator is 1 less than the denominator. And that's a little trick that we learned. Okay? Now, I want to look and turn your attention to these two fractions here. What do we call these fractions when the numerator is bigger or greater than the denominator? These fractions are called improper fractions. They're top heavy, okay? That numerator is way bigger than the denominator. Now, just like how we simplified this fraction, okay, we have to simplify improper fractions as well. We can't leave an improper fraction like that. Excuse me. So what we need to do is we need to simplify this improper fraction. So how to do that, okay, we simplify improper fractions by dividing, okay? And you may not know this, but this line between the numerator and denominator stands for division. So this fraction, another way to write 14/3 is just to do 14 divided by 3, okay? And this one right here, 42/7, is the same thing as just saying 42 divided by, 42 divided by 6, 42 divided by 6. Okay, so to simplify these fractions, all we do is divide. So right here, I just have a little division template. So we can do 14 divided by 3. Okay, so now we can solve it. 3 goes into 14 how many times? It goes in 4 times without going over. So that's 12. And we get a remainder of 2. Okay, so 14/3 simplifies, guys, is 4 wholes and 2/3. So 14/3 simplified. If you want to make a little new little text box, okay, and you want to write that down, okay, 14/3 simplified, we just take the whole number, so that's 4 big wholes, that's our whole number, and then 2 out of 3. So 2/3. So these two things are exactly the same. Okay, so let's look at this next one, 42 divided by 6. We can fill that in, 42 divided by 6. 6 goes into 42 7 times. We get exactly 42, and we get a 0. Okay, so in this case, it doesn't have any remainders. Okay, so the answer to this problem, 42/6, to simplify it, is literally just 7 wholes. Okay, so if it has no remainder, it's just whatever you get up here. If it does have a remainder, the remainder is your numerator, and whatever your original denominator is, it stays the same. So this is 4 2/3. And we're going to get a little bit more practice of that. Okay, so I wanted to go over improper fractions with you because you are going to see these throughout the rest of this topic. Okay, so now all we're going to practice today is just estimating sums and differences of mixed numbers. And we'll get back to improper fractions in a bit. So I just wanted to review really quick the equivalence to half. Okay, so we have half, and again, you're typing these in, so you can just do the number slash the other number. You don't have to try to make it a fraction on top of each other, okay? Equivalent to half. Now, we could also do 2/4 is equivalent to half. And it's important to know these half equivalents because of this rule I'm going to talk about in a second. So we have 1/2, 2/4, 3, what? 6, 4/8. And again, the numerator is just doubled to get the denominator. That's always how you get halves. Let's skip up 5. 5/10. 6, double it, 12. 7, double it, 14. And we can keep going. 8/16, 9/18, 10/20, and so on, okay? I just want you to be familiar with these half equivalents because the rule that we use to make estimates for mixed numbers, okay, remember the rule. If the fraction is half or greater, round up. Okay, so if the fraction's half or greater, round that whole number of the mixed number 1 up. So for example, 1 and 7/8. Look at this fraction, 7/8. Is that less than half or greater than half? If you're not sure, look at our equivalent half with the denominator of 8, 4/8. Well, 7 is greater than 4, which means that it's greater than half. So this fraction is greater than half, which means we take the whole number, which is a 1, and round it up to a 2. Okay? When we round mixed numbers, guys, we round to the nearest whole number. So we get rid of that fraction part. All right? What about the next one? We have 5 and 1/3. Is 1/3 greater than half? It's kind of hard to tell because there's really nothing here for thirds. But 1/3, if you know your fractions, is actually less than half. Okay? So if the fraction is greater, you round up. If the fraction is the same, it's just like regular rounding. It stays the same. Okay? So if the fraction is less than half, it stays the same. So the 5 just stays a 5. Okay, we're rounding to nearest whole number. The next one, 10 and 12/30. Okay? Now, we don't have a 30ths up here, but, okay, what's half of 30? 15. So a half equivalent would be 15/30. What's greater, 12/30 or 15/30? 15/30 is greater. So that means that 12/30 is less than half. So that means we keep the 10 the same. And the last one, 3 and 6/10. Okay? Well, 5/10 over here is half. 6/10 is greater than half. Okay? So we take that 3 and we round up to a 4. All right? And that's all we're doing for rounding mixed numbers. So let's look at the next slide and kind of do some practice with adding and subtracting mixed numbers, but we're rounding them. Okay? So you tell me, would 2 and 4/5 stay 2 or round up to 3? It would round up to 3 because 4/5 is greater than half. What about 3 and 2/5? Would that stay at 3 or would you round up to 4? This is a little tricky, but 2/5 is actually probably closer, less than half. Okay, so in this case, we would keep 3 the same, and it would be 3 plus 3 to get 6. The next one, 7 and 5/8. Is that greater? Is 5/8 greater than half or less than half? It's greater than half, so we would round up to 8. 4 and 7/20. Will we round this whole 4 up to 5 or keep it at 4? We would keep it at 4 because 7/20 is less than half. 10/20 is half. So that's why it's important to know those half equivalents, guys. So 8 minus 4, this problem is about 4. Do the last one by yourself. What do you get as your estimate? 7 and 2/5 plus 5 and 7/9. Well, 7 and 2/5, 2/5 again, look at that one, is less than half, so we'll keep it at a 7. 5 and 7/9, I would say 7/9 is greater than half, so I'd round it up to a 6. 7 plus 6 is about 13. So our estimate's around 13. All right. So really quick, I just want to practice at the very end of this to practice changing some improper fractions to mixed numbers, because I said I would kind of go over that again. So let's say we have the improper fraction. Let's see. Let's say we have 25 sevenths. Okay. So remember, this fraction actually is really just saying, because every fraction is a mini division problem. 25 over 7 is the same thing as 25 divided by 7. So if we set up a little division problem, 25 divided by 7. 7 goes into 25 how many times without going over? 3 whole times. Okay, so this 3, guys, is our whole number. So 3 wholes. 7 times 3 wholes gets you close to 25, but that's only 21. So we subtract. 25 minus 21 is 4. If we can't come do it anymore, 4, guys, this is our numerator. So it goes in 3 times with 4 left over out of whatever you started with, 7. So 25 sevenths is the same thing as 3 wholes and 4 sevenths. And guys, this is the simplified version. Now, you may need to simplify the fraction later on when we move forward. But for right now, this is the simplified version, 3 and 4 sevenths. We don't want to leave it like that. All right, so let's do another example. Let's do 32 sixths. Okay, so again, 32 over 6 is the same thing as just saying 32 divided by 6. So what I want you to do right now is to get a scrap piece of paper out and just write 32 divided by 6. Okay, how many times can 6 go into 32 without going over? It can go in 5 times. So 5, guys, is our whole. 5 guys, haha. Okay, 5 is our whole number. 6 times 5 is 30. It goes in 5 whole times. Okay, and you end up getting what as your remainder? You get 2 as your remainder. Okay, and it can't go in any further. So with 2 left over, okay, so this is our numerator. Our remainder is our numerator. Remainder, numerator. And then whatever you started with, the 6 is the denominator. 2 out of 6. So this 32 6 is the same thing as 5 and 2 6. But this is a scenario where 2 6 we still can simplify. So 5 and 2 6 is really equivalent to 5 and what? What can you simplify 2 6 into? Well, you can divide top and bottom. They're both even by 2. So you get 1/3. So 32 over 6 or 32 6 is the same thing as 5 and 1/3. Pretty cool. And we will get more practice of this when we move forward as well. So what you guys are going to do, there is going to be a Google form, okay, that is going to be in your classroom to complete for today. You're going to be making estimations on the Google form, and you're also going to be changing mixed numbers or improper fractions to mixed numbers. All right, so you're going to get a little practice of both. So take your time on that. If you do have any questions, please let me know, and have a wonderful day. Bye, guys.